At Simio, we're in the business of showing you the future. Our intelligent technology gives you unprecedented insight into complex systems to identify and solve today's inefficiencies and tomorrow's challenges. The Simio solution provides a low-risk opportunity to drive transformational change. Our true digital twin models capture all the constraints, business rules, and decision logic that define the operation of your system. When powered by your data, easily evaluate unlimited scenarios and deliver optimized solutions. No matter what industry you're in, eliminate your greatest operational process and scheduling challenges with a Simio digital twin. See your future success, Simio.
Welcome everyone to 2025 Simio Solution Series. Happy New Year to everyone. Welcome back to our sessions here for 2025. And welcome to our new platform that we're doing this on. Hopefully everyone found their way here okay. We had been using a different platform, the GoToWebinar platform, for the last several years. We switched over to WebEx this year. And as it is with the first time using any platform, we'll work through our little hiccups or bugs together here. Nothing so far, so 3 minutes in, and I'm pretty happy about how it's going, at least so far. All right. So I am Dan Vassaletti, the Vice President of Global Sales over here at Simio. Hopefully met everyone on this call before, or at least you've heard of me before. Doing most of the talking today is me, Adam Sneath. Adam leads up our solution engineering team. You can see both of our email addresses there. So what I will do is you either jot those down now, or as we get to the end of the presentation, if questions come up and you haven't had a chance to ask them, you can reach out to one of us directly. You will see 2 times during this opening presentation here a QR code there somewhere on your screen. We would ask that you scan that QR code, give us some feedback on today's session, as well as any future ideas you may have. But we'll talk about what today's session is all about and what we have coming up, at least planned for the next 2, and then we could talk about futures after that. So today's session is building blocks of Simio modeling, and this is part 1. This is a 3-part series we're doing. First part, obviously, today, February 19th. As far as the next 2 sessions are concerned, they will be coming up in March and April. Before I go into that schedule, though, to get things started, a few housekeeping items. Today's session is being recorded for replay purposes. You may have heard that recording started there at the beginning. So if you would like to go back and watch this session at a future time, or refer it on to a colleague or a friend or someone else, just go to Simio's webpage. We did revamp our webpage towards the end of last year. If you go to the webpage, you should see a resources tab up the top right, and just navigate down. Solution Series is the first button down after the resources tab, so it's pretty easy to get to. And this, as well as all prior Solution Series that we've done, are available to watch there. So we've got dozens and dozens of them out there now. We've been doing this now for almost a little over 2.5 years, almost 3 years. So there's a ton of content out there, lots of different sessions for both beginners, intermediate, and advanced sessions. Also be aware of today's session, you are muted during the presentation. At least we hope you are. We attempted to make sure we had all the keys set up correctly to try to keep any overlap or feedback going. So you are muted for today's presentation. If you'd like to ask a question, on my screen, there is a Q&A panel, like on the WebEx attendee panel on the far right side, bottom right, you'll see a QA. That's how we believe it should be for everyone out there. If it's not, just search around. There should be 3 dots somewhere. If you don't see the QA, hit those 3 dots and the QA button should pop up there. Type your question in there. Those questions come directly into everyone that's available here on the panel today. Generally, what we'll do is I'll get those questions in. I will read them out loud to the presenter when the time is appropriate. Sometimes there is a good break point where I can ask the question and it's relevant to the topic we're on. Sometimes we hold the questions till the end as they're more generic in nature, but we'll try to manage those as we go. Today's session is scheduled for 60 minutes. Adam's got about 45 minutes or so of presentation to go through. So that we should finish with a little bit of time there at the end for Q&A, depending on how the questions come in during the session. And like I mentioned, this is session one of a three-part series. So next part is going to be March 19th. Last one will be April the 23rd. These sessions are intended to build upon each other. So if you're watching this session live here today, or if you're watching this session on record, and we've already gone through March 19th to March 23rd, perhaps it's later than those dates, we would highly recommend you go back and watch the February 19th session first as the first session of this. The intent really of these three building blocks is going to be for the new user, the infrequent user, the person just getting into Simio for the first time, or relatively new into Simio, really giving you a foundation on where you start, how you get those models started to be built, all the way up through trying to have a model that's producing something for you. All right, lastly, we do thank everyone for attending today. Once again, there's that QR code. So if you didn't scan it earlier, this is another chance to scan it. You will have one more chance to scan it after Adam's done talking today, when I revisit our email addresses. But at least for now, if you want to scan that QR code, keep it up on your phone, and you'll be able to give us feedback when we are done today. So with that said, welcome everyone once again to 2025 Solution Series. Adam, I'll turn things over to you, and we look forward to getting questions along the way. Adam, it's yours.
Great. All right. Thanks, Dan. Share my screen. And Dan, can you confirm you can hear me all right and see the PowerPoint?
Confirm the PowerPoint showing, and you sound good.
Good deal. All right. Hey, welcome everyone. Thanks so much for joining. Really excited to kick this series off this year. And as Dan mentioned, yeah, this is really going to be geared towards new users of Simio, but may also be interesting to experienced users from kind of an education and ramp up standpoint. So if you have a big modeling team, you've been doing this for a long time, maybe you're bringing new engineers or new modelers on board, this series could also be interesting to you as well. So I always like to start with sort of an open-ended prompt here. I'm working on my first Simio project. Where do I start? Well, let's take a look at how we're going to get you there. So the first thing we ought to do is understand the landscape of Simio. So we're going to introduce the interface and clarify some of the different terminology that you'll see in the software user interface. So we have a common language. Next is the work that we need to do before we ever open the software. Some keywords that I like to think of are conceptual modeling, of course, gathering information and data for the model. As you know, if you've been doing simulation, it's widely applicable to a lot of different systems. So this part of the project may look quite different if you're in a manufacturing setting, or if you're in a service environment, or you're in a warehouse. But generally, the philosophy is the same. So I have sort of a mock example that hopefully will illustrate how you go about this, because that can be challenging. Well, let me put it in positive terms. If you nail that part, the conceptual modeling, you can really be set up for success with your modeling. We're also going to look at the standard library objects plus the drag and drop paradigm for building a model, object properties, and the expression editor. Really, we're going to focus on entity movement and routing. So how do I basically take the value stream and get it into my model? What product are we making? How's it moving through the system? So we're going to focus a lot on that, and also analyzing pivot grid results to give us some feedback on what the model's doing, how the system is performing. And I've tried, we had a similar webinar last year that was sort of fundamental concepts. So I've tried to avoid overlap, but I think really the two videos together plus the two that are coming up will all be a good complement. So if you tuned in last year, hopefully there will be some new concepts in this one. So thinking about that first step, what are we modeling? And this slide in particular, and the example today, is going to be geared towards a simple manufacturing setting. So the first thing I think about generally are what are the products? What is our mix of products? Do we have orders? Do you have sub-assemblies, right? So what are we making? And how is that demand kind of coming into our system? We'll see the arrival patterns. We're also going to focus on processing times. So, and kind of the piece in between there is routing, right? So how do these products move through the system when they get to equipment or resources? How long, are their cycles? Outputs. So important to kind of work with your stakeholders and understand what are the business KPIs that we want to measure in the model. And sometimes these can get confusing. Sometimes people will think about throughput, for example, as an input because you do have kind of input rates of materials coming into the system, but throughput is going to be an output that we measure in the model. So how much did I make over time as finished goods or finished products? We're also going to focus on kind of buffer times and parts, TIS or time in system, really just for kind of some verification and validation. And then in parts 2 and 3, we'll focus more on the analytical aspects of simulation. Then there's a validation piece in between here. We'll see that a little bit on the next slide, but this is more like trying to improve the process. So using the model for experimentation, scenario comparison, process changes to see, can we improve performance, alleviate bottlenecks, etc. And from a project management standpoint, this is the recommended timeline or a recommended timeline of steps you might follow. And I won't belabor this too much because I've alluded to some of it, but the first step is really clearly identifying what are the business questions you hope to answer. Do you have problems with inventory, labor? And these can be qualitative in nature. So you're working with stakeholders or SMEs to understand what are their pain points, what are their gaps in understanding or grasp of the process. Then we'll work toward a baseline model of the current state. So generally, unless it's a greenfield or a totally new system, you're going to model the current state. And that exercise includes thinking about how much detail do you need in that model, which should really be driven by the business questions. Some of that comes with experience, but one way to think of it, and some may disagree with me, but this has been my experience doing this for about 5 or 6 years, is I tend to start with less detail and get some volume going through the model, just so I can start to gauge the result. So if I start with a pretty low amount of detail, I'm looking at throughput, and my throughput is way higher than the actual system. I've probably under-constrained my model, or I certainly have under-constrained my model. So then I can look at it piece by piece and think about, where did I leave something out that in the real system is, slowing us down? But starting with less detail allows you to kind of get it built up faster and get on towards this validation and decide sort of iteratively where you might need to add details. So we don't want to over model up front. We're going to try to avoid that. Then we're going to run that model maybe with last week or last month's demand and compare our model results to actual performance to build trust that the model is accurate. So I'll talk about validation with the A is accurate to reality. Then we'll clarify verification and how that's different shortly here. Now, once you've got a good handle, you feel good about the model, then you can move on to kind of future state analysis. So let's run some experiments, pull some levers on the system, and see how our KPIs perform. Then finally, you may implement improvements in the real world based on what you learned from the simulation, and you can loop back. As you have new questions, you might just run additional experiments in that same model, or you may revisit the base model as the process or the system changes. So we'll get started with the interface. I've just set up this slide really simple to give us a little context before we look at the software. So across the top, we have what I call ribbons. I noticed some of the nomenclature in our documentation calls these tabs. I like to call these ribbons and these tabs just to distinguish them because they're pretty similar look and feel. So we'll refer to run, drawing, animation as ribbons, facility processes, etc. as tabs. Then I also have various windows in the interface that are generally labeled. So for instance, on the right-hand side, we'll see the navigation window and the properties window in the software. So let's take a quick look here. And we're now in Simio software, and you'll see exactly what I had on the slide. So a number of ribbons across the top, and we'll introduce the functionality of some of these today, and likely all of them by the time we get through the three-part series. We'll also work through 4 out of 5 of the tabs today. Processes will be covered in one of the follow-up sessions. Then we think about the windows you see on the left-hand side of my libraries. We're going to focus on the standard library of objects today, navigation window here on the right, and properties window also here on the right. Another good habit to get into with Simio is you hover on things like the server object or click on a property. Our developers have done a wonderful job trying to give you tool tips or a quick indication of what that thing might do, or a quick description. So we're going to jump back quickly to the PowerPoint and sort of set up what we're going to build here as our example. Thinking about that kind of data gathering phase, I've created 2 examples of common kind of inputs you might have when you're scoping this out. So first we have a value stream map, simple manufacturing process, 3 departments, turning, milling, finishing. We have 4 pieces of equipment in the turning department, 2 in milling, 3 in finishing, and we're making 3 types of parts. So we'll also see with the lines that they have sort of different routing requirements. So widget A needs to go through all 3 departments before it's shipped. B will go through turning and finishing and then exit. C will go through just milling, finishing, and then exit. And we also have a mix table. So we've perhaps looked at our historical demand data and determined that approximately 60% of what we make is widget A, 30% B, and 10% C. So when we get started, we're first going to introduce the equipment, then we'll introduce some entities to represent our products. So let's flip back to Simio and get things started. So the first thing I'm going to do is drag and drop 3 servers out from my standard library. So most of our model building work will be done here in the facility tab, facility grid. You can see that it is a 2-scale grid, so I have kind of meter markers here, and that's really optional for you. So you can model to scale if maybe you have an AGV system or a lot of worker movements that you want to capture with sort of spatial accuracy. What you might do in that case is if you have a blueprint or a CAD drawing, you can actually import that. So we're in the drawing ribbon, you can import a floor plan, set it to scale, and build your model on top of that. It can be a really nice option if you have that available. We're not going to do that today because you can also model and sort of use this as more of an abstract space. And there's other ways you can control how long it takes to get from A to B, other than having, space and speed dictate that. So to get started, we're just going to create 1 server for each type, each flavor we have in the various departments. So we'll say turning 1, milling 1, and finishing 1. And instead of kind of walking through everything the server does right now, we'll do that in stride. So just bear with me as we get started. But I'm also going to introduce just a bit of animation to these objects. So when I'm working on a project, I go for kind of just enough animation to help me tell a story with the model. So to do that, we'll select the object, and you'll see that I have these ribbons that apply specifically to the selected object. So I can take a symbol from our symbol library and apply kind of a lathe, look and feel to turning, a milling machine, and then a piece of equipment there for our finishing resource. Now we flip down into 3D. You see I have a little bit of real feel on those. You can switch between 2 and 3D using the 2 and 3 keys on your keyboard. Also, if you hit H on your keyboard, you'll get some tips for navigating around the facility, moving things around, and you can hide or reveal that message with the H key. All right, so now we're going to keep this really simple and just use good old copy and paste to introduce 4 turning objects, 2 milling machines, and 3 finishing resources. And just take a second to give these a little bit of better names. So we'll have turning 1, 2, 3, and 4, matching our value stream, map, milling 1 and 2, and finishing 1, 2, 3. All right, so we're moving along. And we ought to also bring out a sync object. So sync object allows entities to exit the system. So sort of where the scope ends for your analysis is where you might put the sync, and we'll call this shipping. Next, thinking about our products, we're going to, from the project library in the bottom left, pull out 3 entity instances. Go ahead and name these widget A, widget B, and widget C. And we're going to give these some coloration to match the flow lines on our value streams. If I'm remembering correctly, widget B will go ahead and make blue. Similar to the objects, when I select that entity, I can interact with it here from these ribbons that appear. Widget C will say is orange. Now, let's see what happens. We've made a little progress. Let's go ahead and run them on. All right, so you can see nothing, evidently is happening here in the facility view, but we can see something here in the bottom left is our simulation clock. So you have sort of 2 versions of this. One is a real valued number indicating simulated hours, and the other is a calendar time. So you can see February 24, 12:10 a.m. And what you see there is primarily controlled by your settings for starting and ending type here from the run ribbon. So for now, and we're going to adjust this, we're just running one 24-hour day from February 24 to February 25. But we ought to make this a little bit more interesting. So let's actually introduce some entities to the system. And of course, we have an object for that. A source object may be used to generate entities of a specific type. And to get us kicked off, we will just bring out 1 source per entity type. Now we get a chance to introduce the properties window. So what you'll notice, and when you're getting started, don't hesitate to just kind of bring out an object and tour around its properties to get a feel. That'll give you a good indication of kind of what the object is and how it's meant to behave and how you can configure it or customize it as the modeler. So the source object has properties that pertain to entity creation, like how many, is there a limit in these stopping conditions? Our arrival mode, our default option there is inter arrival time, so time between arrivals. What type of entity do I want to create from this source? So we'll make some quick adjustments here on source 2 and 3 to create the corresponding type of widget. And we look at this inner arrival time, random.exponential. We'll talk about this in a moment, but first note that we have time units, right? So if I simply said, a quarter of a minute, every 15 seconds, I would get an entity. Now, if you ever change a property value, so property name and value here, the value is what I added as the user, you can right click and reset. And now I've clicked into the expression editor. And I'm going to pull up one of the help documents in a second just to give you a kind of reference point on this, but Simio expressions follow this dot notation. So if I type random dot, I see all of these distributions that I have in, generally in that random namespace. We're going to focus on a couple of these, like uniform, a couple common ones, triangular. Exponential is common for arrival processes. I always think about sort of pulling up to, a drive-through. You can look at the shape of an exponential distribution. So it has one parameter being a mean. This represents a Poisson arrival process. So certainly don't hesitate to kind of read up a little bit more on this and how it works. But the key thing to note is that we're sampling from this distribution every time an entity is created. So it's mean is a quarter of a minute, but sometimes it could be longer. So the exponential distribution has kind of a tail. So it might be 2 minutes sometimes, or it might be 5 seconds sometimes. We'll see how that plays out. So I'm just going to leave that as is for now. And now again, let's take a crack and just run the model. So you can see we've at least accomplished, we are now creating all 3 flavors of entity. But the first thing you probably notice is that our routing, it was very haphazard. So that's where we now kind of tee up the next step of let's actually route these parts through the system strategically or following our value stream. So the first thing you might think of is using paths. So paths can be used to connect objects and instruct entities to, follow the linkages between objects. So we've said from the value stream, A needs to go to all 3 departments. B just goes turning and finishing. And C, another quick trick here is if I double click, I go into kind of multi-place mode. So I can click from A to B and then from B to C and kind of repeatedly click to introduce more paths. So perhaps a little bit better. Now our products will follow, along the paths that we've drawn, but this isn't really what we want. So given that we have resources in parallel, we sort of want, a work queue ahead of each department, and then maybe some kind of rule as to how we select resources within that department. So we'll take this as a win so far. Pause, stop the model, and I am going to right-click the model in my navigation window and make a copy just so we kind of preserve our first iteration. And this one we'll call routing and mix. And the first thing I'm going to do is undo what I just did with the paths, because we're going to introduce a couple different routing techniques in this next iteration. So just kind of a natural pause point there, Dan. We'll see any questions have come in or any comments so far.
Yeah, no, good timing here. So there was a question that came in as a little bit earlier when you were going through your initial presentation. And I think it's a good question to get out there. So how long would you say it takes to validate a model? In this person's experience, the word they use is woefully, it's underestimated by a lot of the modelers that actually go through the process. So how long would you think is a reasonable time to validate a model?
Yeah, so it really depends on the scope of the model. If the model's really complex, you might need different parties or different personalities to review the results with you and, gut check. So if it's really complex, that could be, several weeks of iterating, getting feedback from the subject matter experts, making revisions, testing different scenarios too, right? So some models are used for sort of a static analysis, like we're thinking about a CapEx. So we want a yes or no decision, is this gonna make sense for us? Other models are more operational in nature, meaning that you're gonna use it week to week. So you may need to put some different data sets through it before you catch something or find a bug. So, anywhere from a couple hours to a couple weeks. I mean, if it's a simple line or portion of your facility, you may run some demand through it. And throughput, I think, is usually one of the first metrics that I would use to validate. So you look at throughput from the model, look at your throughput from the system. If they're in agreement, maybe plus or minus 5%, maybe you run a few more tests and you're good to go. But if it's a complicated model, that could be an iterative process. So tough to give one answer, but hopefully that helps.
No, that's great. That's great. All right, a couple more questions based on what you were working on. Is it possible for all three entries or entities to be generated by a single source?
Sure is, and we're going to do that in just a minute.
Okay. All right. So for that questioner, that is a to be determined. It's coming. All right. Next question. They're typing it as we speak. Actually, go ahead. Well, actually, no. Let me ask the question. If I have 100 different products, would I need to create 100 different entities? Is there an alternate way to represent all those different product types, et cetera?
Yeah, certainly is. So one of the benefits of having multiple instances, like I drag and dropped, separate instances of these out, is Simio is going to capture statistics separately for each instance. Now, if you have really any more than maybe a dozen, you can use key codes. So if you have SKU codes in a data table, as you create entities, you can assign them a SKU code, and then you can put in sort of custom statistics, or you have a record of data basically for each SKU code where you can kind of track information about that bucket. So you can definitely do it with one instance type and using some key codes. If that's something you're facing in your project, reach out and we can take a look at setting that up, because I won't cover that specifically today, but you definitely can. Good question.
All right, perfect. All right, so you're going to address the three entities generated by a single source here. So we'll leave that question open, and that's all that's in the queue right now.
Sure am. All right. Thanks for the engagement. So let's think about that slide again, right, where we had that mix table. So 60, 30, 10, top to bottom is approximately our mix of products that we want to, that we have to make, we want to bring into the system. So I'm going to flip to the data tab, and you'll see in the data tab, I have ribbons that now correspond to data things, like adding a table from the schema ribbon. Once I add the table, I can give it a meaningful name like table products. And I'm going to build two columns, again, from the schema ribbon. I'm going to have an entity reference property column and a real valued column. So my entity column, I'll call it part type. And my real property column, I will name mix. Now, being an entity column, I have the option to select from the entity instances that I have in my model. And real valued, I can enter numbers with a decimal notation to introduce that mix. Now, data-driven, anything is kind of a buzzword, but when I think about data-driven modeling in Simio, it's sort of two steps, like give me the data and then use the data to drive the model. So that'll be our next step. Another thing to note from the content ribbon is you can use these data bindings to pull data in from a handful of different sources, flat files, database, cloud sources. So if it's a small table, something like this, you can build the data manually here in Simio, or you can pull it in, which you would almost always do for bigger data sets. So on the driven part, let's see how we can apply that mix. Now, when I look at my single source, I have an option to reference that table name dot column name. So same sort of dot notation, and I promise to pull up. So as a new modeler, the support ribbon is really your friend, both specifically the help docs and Simbits. And so I'll load the Simbits here in a minute as well. But if I wanted to learn more about the expression editor, I can search that. A little tip is if you hit refresh, the highlighting goes away, and you can read a lot more about how that works, some of the different kind of common functions, so on. So definitely get comfortable kind of using the help docs. They're really, really thorough. But we'll see what this green arrow is telling me. You know, I'm kind of pulling this value from somewhere else. And all I've said so far is look at this column. I haven't told this anything about a row. Now, of course, we're going to do that, but I want to just show you what happens if I run. Cannot determine the row to use in that table, which makes sense. I didn't tell it anything about a row, and there's 3 rows there. I just pointed to a column. So before creating entities, I can establish what's called a row reference at the source. And if I hard type a 2, now this reference can resolve what row in that column to use to get the value of entity type, right? So I type a 2 and I get all blue parts. I type a 3, I get all orange parts. Now, actually, what we want to do is sample the mix values as weights, and we have a function, kind of one of the common functions specifically for doing that. So I hover returns the index of a randomly selected row. The probability of selecting a row is determined by the values as row selection weights. So let's put that in kind of plain terms. What that means is the likelihood of selecting any row is its weight divided by the sum. So 0.6 over 1, 60%. All right. So now we start to think about verification. So that with the E in verification, I think about errors. Every time I do something in the model, I want to make sure I check, watch it, look at the results, make myself believe that I didn't model it incorrectly, that I modeled the behavior that I was going for. And one of my colleagues always said, you want to form an expectation before you hit run. So if we've done this correctly, I should see mostly green, a decent bit of blue, and occasionally some orange products in the system. So we see green, blue, and every so often we'll get some orange. Now we can actually do one better. How do I know? I mean, it looks okay, but how do I further sort of check that those percentage mixes have been applied? So we're going to set our ending time to 2 hours, fast forward all the way to the end, and take a cut at our pivot grid results. So I'm going to specifically narrow in on this number created option and filter down. A nice feature here in the pivot grid is you can save views, and then you can always reset to unfiltered or quickly snap back to kind of a custom view here. So at risk of doing the mental math wrong, oh, you can see I already did this earlier, which will save me a little time with my formula. But when we take the number created of any type divided by the total sum, about 59%, about 31%, about 10%. So that gives us some more confidence. This is number created of each type, that our mix, and now remember that mix is still stochastic. So if we were to run 1 million entities through, you know, as the number of entities increases, we would trend towards 60, 30, 10 exactly. But got enough trust that we've incorporated that mix correctly now. Great. So making some progress. We've got the resources from our value stream. We're creating our products with the right volume. Now the next, we're going to spend a bit of time now on routing. So what we really would like to have is sort of a work queue for each department. So to do that, I'm going to use a transfer node for each department. And we'll call this simply turning, milling, and finishing. This gives me kind of a consolidated point before the department to get things to the various resources. Now, when I think about routing, our transfer node is sort of the window out of objects. It can also stand alone. But when I look at the properties of the transfer node, I have an entity destination type. Do I need a vehicle to take me where I'm going to my destination? I would say those are maybe 2 of the most common properties you'll interact with on the transfer node. And we have a list of options there. So continue is what we've seen so far. Continue will just send you to the next closest node if you're traveling in free space. So anytime the entities are just moving through the grid, not on a link, that is called free space travel. So that continue option just sends you to the next closest input node. So I drag this one over, you see they go here. I drag it farther away, they just go to the next closest node. Let's see what else we have. Specific would be kind of like hard typing one destination. We're going to focus on by sequence and select from list. So now we're thinking about that value stream map and the flow lines. And we're going to use something called a sequence table to introduce a routing for each product in our system. So back to data, schema, add sequence table. I'm going to call this table routing. And a sequence table is created with this. If you read the tooltip, it'll tell you a bit more. A data table that has a destination column used to specify a sequence of destinations for an entity. So sounds potentially helpful. We'll see what we can do. And you'll see the options in that sequence destination type column are nodes. So I'll use this column to define a sequence of nodes that my parts are going to follow. One other thing I'm going to do, and I won't elaborate too much on this just for the sake of time, is I'm going to set up my part type column as a key, primary key column. If you have any background in kind of database or data science, means that only unique entries are now accepted as a primary key column. And then I can have sort of a child relationship in this table or a foreign key relationship. So when I add a foreign key property, it asks me what my table key is. I'll select that primary key we just established, which is the only option you see there because it's the only primary key in my model. And what that allows me to do is define now a routing kind of conceptually for each type of product, right? So I could say widget A is going to go turning, milling, finishing, and ship. Actually, it will be input at ship because that's the name or input node at shipping. Widget B, and you can tab through these tables with your arrow keys and use copy and paste to kind of speed things up. I'm just going to pull, I'm going to cheat, pull this up on the side. Turning and finishing is what we need for widget B. Turning, finishing, ship, input at ship. And widget C is going to follow milling, finishing, and then input at ship. See if we can really be lazy and copy and paste. All right. So you can also see it's called this master detail view through this drop down from the primary key table. Now I have kind of a sequence defined for each type of product, just to the departments for now. All these tabs are sort of modular. If you want to put it on another monitor or put it in split screen, sometimes that can be kind of nice to manage your screen real estate. Now, again, on the driven part of data driven, we're going to use that by sequence entity destination type, which is specifically meant to work with a sequence table. So again, you'll get a tooltip down here. If you wanted to learn more, if you've never seen this before, and you're interested in kind of following up or building out your knowledge, Symbits would be a great place to do that. So if I come into my Symbit library and type sequence table, we actually have a category dedicated to that. There's a handful of Symbits. When you click this, it'll open a model and a PDF. It's kind of a small targeted model on a specific concept, and there's hundreds of these. So really great resource for learning Simio, kind of along with the help docs. So we'll head back, and now I'm going to do the next step here as well, and then I'm going to explain why. All right. So we also want that by sequence option on the output nodes of all of our equipment. At our department nodes, we're going to set up another type of routing kind of a shortcut, or what do you call it, spoiler, we're going to use select from list to kind of route to equipment within the department. But I'm going to use the properties spreadsheet from the project home ribbon to select transfer node type. And that gives me sort of this grid view of all my output nodes. And then what I can do as I select here from the properties spreadsheet, you can see it's kind of similar to that control click for multi-select. Anything that I've multi-selected, I see like properties that they have. So all these output nodes have the same property. I can change the value here. I can change it down here and copy and paste. But now they're all set to by sequence. And I'm going to explain to you why that's what we want to do. So kind of the simplest way to think about this table is that every time the entity hits a node with that by sequence option, its row reference gets incremented. Okay, so it comes through the source, and let's watch it live. So to help us, I'm going to just allow widget A, another kind of good test of our mix column, right? And I'm using the step button to just step through. So it actually routes through that turning node, and then the turning is just left to continue. So we're not totally done yet, right? But you can see that it hits the by sequence node there at the source, and as a result, it goes to turning, okay? Now the next by sequence node is here on the server output, and that's going to send it to milling. Happened a little bit fast because I didn't put my breakpoint on. Breakpoints are a nice way to kind of stop the model at some point, but sends it through to the next node in the sequence column, milling. Now let's just do one more quick check and only turn on orange and see what happens. Forming an expectation before we run, we would expect orange to go first to milling and not go through the turning department, right? Step, step, straight to milling. Okay. So we are making good progress. Taking a quick look at my notes here. Good. Okay. We're on track. So I'm going to go back to our correct mix here. And to kind of round out this routing, what we want to do is when we go through the department node, we want to send parts to the resources within that department. So when we look at the option, select from list feels potentially right. So I want a list of multiple candidate destinations. So I make that change. Simio asks me right away for a node list. Now, if you get an error and you double click, it'll kind of snap you to where that is. So I know I need to create a node list. Where might I do that? Definitions lists, node list. I'm going to call this NL turning and select input turning 1, input turning 2, input turning 3, input turning 4. So now I have a list of those input nodes, which would be my destinations from the department queue. And I have some great options there to control how we select a destination from that list. Okay. Now, bonus, if I control click input nodes, there's a shortcut. There's a handful of these shortcuts in Simio modeling. So if I control click, then right click, I can create a node list here from the facility view. I'll call this NL milling. I'll do the same thing for finishing. NL finishing, and toggle the settings on our department nodes. Random. Select from list, finishing random. So now we have sort of a hybrid routing method where our routing data gets me to the department, and then from the department, I should nav to one of the resources therein randomly. Now we're watching, it looks like I'm getting green and blue on turning, a little hard to see. I think I saw an orange one go to milling. again, there's got to be a better way to check. Are we routing things the way that we want? In fact, there is, and we're actually going to use the Gantt chart to help us with that. So if I go to the Gantt chart, I can see a tip that I need to follow to kind of turn it on. At least one resource must have log resource use set to true, and enable interactive logging must be turned on from advanced options. All right, so advanced options, we're going to turn that on. And that log resource usage is an advanced options property there of the server. So again, I'm going to use the properties spreadsheet to select servers, go to advanced options, category, and log resource usage. And now I've got it on my clipboard, copy and paste. Go ahead and fast forward and take a look at our entity Gantt. So now I can see pretty clearly widget A is going through resources in all three of the departments. We scroll down to B. See B is just doing turning and finishing. We scroll down to C and find it. We should see just milling and finishing specific resources in those departments. All right. So I've planned a bit more, but I want to be sensitive of time. I'm just looking at the clock. So probably should prioritize answering questions if there's some out there, Dan. If not, I can continue, but what do we got?
Yeah, no, there's actually a nice little list of questions here. So let's get through some of these questions, then we'll figure out if there's more time available.
Yeah.
First question that someone asked in general was session recording. And yes, the answer is this session was recorded, is being recorded, and it will be on the Simio webpage. I will flash a quick slide up here after Adam's done talking just to show you how to access it, but it's very simple. On the resources tab, drop that down and Solution Series will be there. Our general rule of thumb is we try to get these recordings up within about a 24 to 48 hour period after we're done. So be on the lookout. By the end of this week, it should be up there. All right. In regards to actual technical questions, if there is a batch of entities, each with different attributes, when is it better to represent it as a single entity instead of creating individual entities? And the example they used was like if sorting fruit by size, if there are 100 fruit versus 10,000 fruit, how many entities are too many?
Yeah, good question. Anytime you're getting to more than 4,000 or 5,000 entities in the system, if you're running on a big, powerful desktop with a ton of memory or a super powerful laptop, depending on kind of what your system is, then you probably want to consolidate. And that doesn't necessarily mean you're cutting quality. Like a lot of big warehouse models, you'll kind of look at just product families instead of individual SKUs. So I would say 3,000-4,000 entities in the system at one time start to slow things down a bit, and you might want to consolidate to a batch or kind of a product family concept of the entity. And what you can do is store attributes on that batch. So you can give it a quantity or other qualifiers that will affect how long it takes to process it or do something. So you can still store generally the information you need there, even though you're simplifying it a bit.
All right, great. Can you model systems with multiple objectives, and how can that be done?
Yeah, I like that question a lot. Can you model systems with multiple objectives? So you think about manufacturing, I mean, with one kind of set of data, you might run through it. Generally, there would be a bottleneck. I mean, a bottleneck, you think about it, it's kind of the limiting factor, right? But as you start to experiment, that bottleneck can shift. So it may no longer be a piece of equipment, it may be labor. So don't limit yourself in those business questions. If you have multiple business questions that apply in one area, model out the area, kind of following the conceptual modeling and steps that we've talked about. And then through experimentation and putting different parameters in the model, you can absolutely test kind of a many-fold scenario comparison. Absolutely. Yeah, I like that question a lot. Thanks.
All right, great. Does Simio allow us to model problems and analyze results using trade-off curves or the Pareto optimality standard?
I'm going to take that one offline, Dan. I want to think
Okay,
about that a little bit.
okay,
Good
no
question.
problem.
Yep.
So the person that asked this question, I will go ahead and bring up our email addresses here at the end. If you want to just reach out real quickly and just say, hey, I asked the question, would you mind, responding to that? We will get back to you. All right, next question. When creating a routing sequence, can we add conditions or probability values for the next destination?
Yeah, you can. With a little bit of customization, very similar structure to what we've done. A little customization, you can do that. So, yeah, if you wanted to collaborate on an example or may have something already we could share, just reach out. We could give you some guidance there.
All right. I have 150 identical processors. Must I create each one in its unique process?
And its unique process. So, interpreting this like 150 pieces of equipment. Is that how you read that?
Yeah, I read it that yes, they answered yes. So 150 identical processors. Must I create each as its unique own processor?
Um, Really depends. I mean, as kind of having the flow to each piece of equipment. Are you interested in sort of the queuing at each piece of equipment? I mean, if you need to look at each one individually, there could be benefit to doing that. And there's another way to create objects that is not drag and drop. You can auto create them from a data table. So if you have the name of each processor as rows in a data table, you can bring in that data, do a few clicks, and then kind of automatically have 150 servers in your model. Yeah, that amount of servers shouldn't slow you down or anything. I don't see any downside to that, but it would just depend on the project objectives if that made sense, or if it made sense to kind of abstract or simplify, similar to the batch question.
All right, I'm thinking this might be for the person that's asking the question. I'm thinking this might be a good one to reach out to us directly. But they did put a follow up in there, Adam. How do I model them as independent processor?
Independent processor. So yeah, I mean, kind of the simplest way to think about a server that we've used here with a capacity of one is it's a piece of equipment that can run one part at a time. So I would say just using the standard server, but I sense there's more to this question. So let's discuss. Yeah.
All right, perfect. All right, that's all that's in the queue right now. I know where you are at the top of the hour. So we have a choice here, Adam. We can take the remaining content you had and put it into building block session 2, or we can continue on here and go a little over time. I know we've already lost a little bit of our crowd, so I would highly recommend we shut down here and just add your session or your information on to the next session.
Yeah, I'm totally good with that. Let me just give you kind of closing thoughts here. So I've really focused on routing, and we've seen kind of two key techniques. Where we would finish this out is adding processing times that are specific to products. So we're running different products on the same piece of equipment, right? A question that comes up a lot is how do I model different processing times for different products on the same piece of equipment? Well, another handy aspect of this routing table is I have a row reference for each product in time as it moves through the system. So we would expand on this by putting in processing time specific to the part and then checking our work again on the Gantt. And another thing we would do next is instead of just randomly routing, we're going to look at kind of the queue times in the finishing area. So the idea is these will have the longest processing time, so there will be some competition. And we'll see that the queues, like the queue times or the number in queue, are not balanced with this random option. So we'd add a little more strategy to this, like kind of check out at the grocery store, pick the shortest queue as a routing goal to kind of line balance a little bit. And then we'll look at the results, and we can also prioritize certain parts to jump to the front of the queue. So just wanted to give you a sense for where we're headed so it doesn't feel like so much of a cliffhanger, but we will build that in to session 2.
All right, I'm gonna grab control back so I can put up our email addresses. But as I'm doing that, there was another question that popped in. I'm gonna ask it. If it's a quick answer, go ahead. If not, we'll have them ask it offline. How do I model defect rates?
Defect rates. I feel like we will cover that in session 2 or session 3. Process logic would be one way to do that. So the rates could be another attribute of that routing data, right? So if you think about, oh, there's some fail rate or some defect rate per product, per piece of equipment. You could put those percentages in the table, and then basically once you've finished your processing at the server, we could put in some process logic to say, sample that rate, if it's 5%, if it hits true, take the part out of the system, scrap it, send it back for rework. So that's one of my favorite first examples to do with process logic. So I'll take a note on that and make sure we try and incorporate it in part 2 or part 3. Yep.
Awesome. Thanks, Adam. All right. And as I said, just flashing up on the screen here one last time, my email address, Adam's email address. If you asked the question today and it didn't get answered, which I think we got the most questions that were in the queue, as I mentioned earlier with our first time here in WebEx, I was trying to get to them. They were coming in a little different manner than normal, but got to all of them. I think we were at least able to ask them all. There might have been one question that was unanswered. For that person that did the unanswered question or got the unanswered question, just reach out to us and let us know that you were the one that asked the question, and we will get back to you. And as I mentioned, there is the QR code for giving us some feedback on today's session. We do appreciate that. And then lastly, for the person that did ask the question about for the recording, so there you go on the Simio webpage, simio.com. Right here, you'll see the resources tab and drop down that resources tab. And the first one is Solution Series webcasts or webinars. And like I said, we try to get these things up there in about 24 hours after we're done with them. So be on the lookout for it by the end of the week. That said, we're 4 minutes over our time limit here. Appreciate everyone's attendance today, as well as we do appreciate everyone's questions. Keeps the session lively, keeps Adam and the solution team on their feet, and which they appreciate. So thanks again for attending, and we will hope to see everyone again here within, actually in 30 days from now on March the 19th for Building Blocks Session 2 or Part 2. Thanks, Adam. Bye, everyone.